Question 5. The table below shows the distances travelled by 7 paper aeroplanes after they were thrown. Distances in centimetres. The aeroplanes were labelled A, B, C, D, E, F, G. Find the median of the data. Lads, what does median mean? Hands up if you know. Median. Owen.
The middle value.
The middle value. What do you mean? Give me an example. Give me like a reduction. Give me the tiniest example you can think of. Okay. So what would be the smallest odd number that's not 1? 3. Okay. So 3. 3 people are in line. Okay. And they have different ages. 10. 10. 15 and 12. Who's the middle person? The middle person is number 12. If we upgrade this to 4 people of different ages, who's the middle now? The middle 2. So for example, 10, 12, 15, we'll add in a 20-year-old. So the median age for example A was 12. What's the median age for example B? How do you get the median age? Add them up and get the average. So it's going to be 27 years between the two of them, which is going to be 13.5. Long story short, guys, for an odd number there is a middle. 1. For even numbers there's a middle. Bringing it back to our question, do we have an even number of planes or an odd number of planes? 1, 2, 3, 4, 5, 6, 7. Let's arrange them in order of size. What comes first? What number? 30 after that? 180 after that? Huh? 200, 250, 302 after that? 330 and 380. Who's in the middle? What number is in the middle? See, 1, 2, 3, 4, 5. The fourth one is in the middle. So who's number 4? 1, 2, 3, 4. And as Owen said, 250 centimetres. Now, find the mean of the data. What does the mean mean? Hands up if you know what mean means. The mean. Jack?
The average.
The average. So, give me an example of when mean is used in every day. Okay, so what about test results? How would you calculate the average distance, Brian?
You'd add all of them up.
Add all of them together and divide by what?
7.
Divide by 7. So what happens when you add them all together? What do we get? Anybody have the answer? 1, 8. And you divide that by 7. And what do we get? Huh? 240. 214?
40.
Sorry, 1, 8.
1680.
Oh, sorry, 1680.
Yeah.
Okay, so I need to get my hearing tested. 1680 divided by 7, and you get 240 centimetres. Airplane D is shown again, and the distance it travelled is measured and recorded in place of the original measurement. What does that mean, guys? How many measurements do we still have in total? How many, read it, airplane D is shown again, and the distance it's travelled is measured and recorded in place of its original measurements. How many measurements do we have in total? Do we still have 7? We do, because it's replaced, not added on. So, we still have 7 measurements, okay? The median of the data remains unchanged, and the mean is now equal to the median. How far did the airplane D travel the second time? Now here's an interesting number, okay? If the median wasn't changed, what does that mean? Where was airplane D? Airplane D was located here. How far up the scales does it have to get before it changes the median?
Above 250.
Has to get above 250. It could also be equal to 250, couldn't it? That wouldn't change the median, would it? So it has to get above the middle value. to change the middle person, you got to beat the middle person. Because currently D is below the middle person. If the median is unchanged, it still means it got a score lower than the middle person. It's like the shot put in the Olympics. Unless you get a number bigger than third place, you don't affect who third place is. Okay? So, what do we know about the mean? What do we know about the mean, guys? The mean now equals the median. So what's the new value of the mean? 250. Mean equals 250. Do we know what value D is? Yeah. Have we figured out what value D is? No. So what do we do when we don't know the value of something? We pick a letter, any letter. Okay? We do X. Now, how did you calculate the mean in part B? You added them all together and you divide it by 7. Let's do the same thing again. 188 plus 200 plus 250. Is that 30 there?
Yeah.
Sorry?
Yeah.
1, 2, 3. So that 30 is? Sorry, the 30 has been replaced, hasn't it?
Yeah.
So it's replaced. So it's going to be 188 plus 200 plus 250 plus X plus 380, 330, 380, 330 and 302. All divided by, what's it divided by, guys? 7. And what does that all equal? 250. Okay, what do we do next? What can we do? Anybody? Who said that? Add them up, okay? So we add them up together. And what happens when we add them up together? What do we get?
1650.
1650 plus X over 7. How would you solve this? We'll go for Taylor. How would you solve this?
Bring X, 7 over.
Bring 7 over. And what happens when 7 crosses the equal sign? And why does it turn into multiplication? Division, you change into your opposite. Addition turns to subtraction, division turns into multiplication. 7 times 250? 1,750. 1,650 plus X. Now what's X going to be then, lads?
100.
X is 100. That is 100 centimetres to make that happen. Okay? Any questions on that one that you didn't understand or you did this earlier? What is the minimum distance the aeroplane needed to travel in order for the median to have changed? Can anybody tell me? Sorry? So, lads, if we get our initial table here, I'm just going to bring back up our initial table. Okay? If we rank them in order, X, it was 30. It was 30, 188, 200, was it 250, 302, 302, what else? 330 and 380. The median is currently 250. And this one here is being replaced. How many places does it need to skip up the ladder to replace the median? How many spaces does X need to improve by to get above 250? It needs to go 1, 2, 3, 4. How does it beat 250? What number will beat it? Any number above 250. Okay? It can't be equal to 250. What happens if it equals 250? The median is still 250. So, therefore, what's the minimum distance? I'd say anything above 250 centimetres. Like, it could be 250, I suppose, technically speaking, they're rounding it off to the nearest centimetre, so you might say 250.5.
Or do you have to say below 330?
No. Because if you get the highest score, the median has still changed. Oh, sorry, no. The minimum distance. Minimum.
Okay.
So you don't want 330, you just want to beat the median. Okay? Alright guys, Is this question 6, is it? Sorry? Data on the type of broadband connection used by enterprises in Ireland for 2008 and 2009 is contained in the table below. Display the data in a way that allows you to compare the data for 2 years. Okay, so how would you do that? So guys, what type of diagrams do we commonly use for displaying data? Let's get a list. Sorry? We'll go with bar chart. Bar charts are usually quite easy, okay, to do. So, bar chart, okay? So, what we want to do is we want to put in the percentage, okay? So we're going to label an XY axis, like so. So an XY axis. Now, we want to do a direct comparison, okay? So, what we're going to do is we're going to link them by type of connection. Type of connection on the bottom. Okay, and what we can do here, what should the y-axis be? Percentage of use. Okay, now we have to figure out a scale. What scale would be ideal? How high do we have to go according to these two sets of values here? How high do we have to go? 45 is the biggest, and what's the smallest? Well, if you're doing a bar chart, it's 0. So we have to go from 0 to 50. Let's count how many blocks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have enough to go up in twos. So we go 10%, 20%, 30%, 40%, and 50%. Okay. Now, what categories do we have to put them into? What's the type of connections we have? Do you see them here? DSL below 2 megs, DSL above 2 megs, other connection and mobile connection. We need 4 different categories. Okay, so here's what we're going to do. We'll put this as DSL less than 2 megabytes. We'll then put another one here. What do you want this one to be? DSL greater than 2 megabytes. And then the gap is 2, just keep the gap as 2 in between. And what about this one here? DSL, other connection, just call it other. And then what about after here? Sorry? Mobile. Now, look at what we're going to do here. We're going to draw 2 different colours to represent the 2 different years. Let the 2008 be black and let 2009 be red. Okay, so we'll just start off with black. Okay, so to do black, how much is it for DSL in 2008? What number? 31. Tell me when to stop for 31. About there. Okay. All right. We'll do DSL. How much for DSL above 2 megs? 41. Tell me when to stop. Okay, thank you. And then finally, other. Once again, tell me when to stop. It's 31, is it? Yeah. So about there, okay. And then, what about mobile broadband? 24, which is halfway between, just under halfway between 25 and 35. Oh, sorry, 20 and 30. Excuse me. All right, guys. Now that I've done that, I now have to do the other one. Okay. So, how far does this one go up then? 29. Just about here. What about the next one? 40. What? 45. Which is here. After that? 20. About here. And after that? 27. Okay, guys. So that's us there. Okay. So that's our chart there. All right. What's part B? Identify any trends which you think are shown in the data. What trends do you think are happening here, guys? What's going up and what's going down? So, Owen, what's going up and what's going down?
The
thing is that if we look at fixed connection went down in comparison to 2008. What's more favoured for this change?
the DSL,
above 2 megs. And what else?
the mobile broadband.
Mobile broadband. And you can say that the DSL under 2 megs experienced the minimum change. So what would you write here on in the box?
The connection in 2008 is better than.
Sorry, what would you write in here? Any two trends.
Yeah, the connection in 2008 is better for DSL more than 2 megabytes.
Okay, so number of customers in DSL. Number of customers in DSL above 2 megabytes increased. What about what decreased down?
The amount of people in other fixed connections.
Other fixed connections decreased the most, yeah? And what else increased?
The mobile broadband increased as well.
The mobile broadband also increased. Okay, so it's best to make as many points as you can, lads, okay? If something goes down, something usually goes up. It's better that you mention them in pairs, okay? Now, moving on, what's the next question we're doing? Number 8? Okay, number 8. There are 24 students in class. On Friday, each student present in class is asked for a number of days he had been absent that week. The results are recorded in the table below. Quick question, guys. What do all these numbers have to add up to? They should add up to 24. So we're going to get 11, 14, 18. This is interesting. So how many students were absent? Because if there's 24 people in the class and we asked it goes 11, 14, 18, 19. Okay? So 19 students are in out of 24. How many are absent? 5. The following Monday, all the students were present in class and the table was updated to include the entire class. Which number from the above table could not have changed? Okay. So which number could not change? Yes, Brian? No. See, Brian, what happened was we added them all together. 9 students were out for none. So they interviewed the class. 9 students said I was out none days. 2 students said they're out for 1. 3 said out for 2. 4 students said they were out for 3 days. 1 student said they're out for 4 days. 0 said they're out for 5 days. But when we added up the number of students that were interviewed, we only got 19. 19 out of 24. And this meant that 5 of them had to be absent. Okay? So on the following Monday, all the students were present in class and the table was updated to include the entire class. Which number from the above table could not have changed? Why did you say none? Sorry? So it says specifically on Friday. Friday is when you attend school. Okay, we're assuming a traditional approach that you're not in school on Saturday or Sunday. And then the next day is Monday. And if everybody is in on Monday, that means none were absent, which means that this number here can't change. Oh wait. Number of students were absent, none. Sorry. So the answer is none, because the 5 people who were absent on Friday would have to fall into the other categories, because they at least missed 1 day. Okay, guys, moving on. What's the next one? Number 9? Oh, sorry, there's part A. The number of days that were missed during the week will depend on the answers given by the students who were absent on Friday. Complete the table below to show the largest and possible number of days missed would arise. So The total days that were missed during the week will depend on the answers given by the students who were absent on Friday. Complete the table below to show how the largest possible and smallest possible number of days would arise. Okay, so let's write down the old table. What's the old table again? Just call it the old table. 9, 2, 3, 4, 1, and 0. Okay, if what we want for the minimum value is, if these 5 students were out, what would you like them, you want these numbers, when you add them all up together, you want them to be the lowest amount possible. Okay, so for example right now, at the moment the number of days missing is 9 times 0, plus 2 times 1, plus 3 times 2, plus 3 times 4, plus 4 times, it's 1 times 4. Sorry guys, I was going to redo the order there. Excuse me. So what's that? 2, 3, and what number goes here? 1, is it? Okay, so excuse me. 9 times 0, 2 times 1, 3 times 2, 4 times 3, 4 times 1, and 5 times 0. Okay? Now what I'm going to ask you here guys is, if you want this number to be kept to a minimum, where should these students be absent? Would it be a good thing if they were absent for 5 days? If the 5 students were absent for 5 days? That would bring up our total. So we would prefer that all 5 students go in to the 1 category. This would keep it to a minimum. So what's 5 plus 2? 7. Okay, so this here would be 7. Alright guys, now that that's done, what about the next question? The largest possible days. The largest number of days possible. What happened if all 5 students miss 5 days? What would that mean? The average would go up, or the number of days would go up. So we should change this 0 into a 5. Okay. Carl decides to draw a pie chart of the actual data collected on Monday. He calculates the number of degrees for each sector on the pie chart. Using this data to calculate the mean number of absences per pupil for the previous week, correct to 1 decimal place. So we got to convert Cottle's pie chart degrees into a fraction, into the number of students. Okay? Now, first of all, can anybody tell me, in a pie chart, what is all the students? What degrees gives you all the students? Can anybody tell me? Can you tell me,
360.
Greg? Sorry? 360. 360 degrees equals how many students? How many students were in the class in total? 24. Okay. What we next got to do is we got to figure out how much each one of these is. So we get these as a fraction over 360. So what's 135 divided by 360? In fraction mode, please. 3/8. So 3/8 of the students were absent for none of the days. So you got to multiply this fraction by 24, and what do you get?
9.
Sorry?
9.
9? 9. Okay guys, what about this one here? 30 divided by 360. 30 divided by 360 multiplied by 24? Anybody? Sorry? 2. What about 75 divided by 360 multiplied by 24? 5. What's the next answer then? The one after that? 60 divided by 360 multiplied by 24? 4. After that? Second last one, 45 degrees? 3. And what's the last one then? 1. Because 45 degrees is 3 times smaller. Or sorry, 15 degrees is 3 times smaller. So there you go. Now, what it wants me to do next is to calculate the mean. Does anybody remember the calculator function that we used to calculate the mean? Can anybody tell me? The stat mode. How did you get the stat mode, Brian?
Shift And then you can
shift, set up.
and go down.
Oh, sorry. Yeah, you're going to put on the frequency, aren't you?
Yeah.
Stat mode. Do you want the frequency on or off? On. Now, how do you get the stat mode now?
Shift.
Mode.
Oh yeah. Start.
Stats. One variable, or which one do I press?
1.
1. Now let's put in the numbers. Okay? This is none. 0. What's next? 1, 2, 3, 4 days missing, 5 days missing. Is 5 days missing the total? The last one. It's the last one. Okay. How many students missed 1 day? Oh, sorry. How many students missed no days? 9. How many students missed 1? 2, 3, 5, 4. 4 days? Oh, sorry, 3 days. I mean, sorry, 3 days. 4 days. 3, 5 days. 1. Okay, guys. Press the clear button. Now, can anybody remember what function I pressed next? Does anybody see stat on the calculator?
Yes.
What colour in writing is it in?
Yellow.
Yellow. Looking at these two buttons here, which one represents the yellow?
Shift.
Shift. Stat. Now, which one do you go into?
2.
Now, 2 is data. Data means you'll just re-enter what you had.
4.
4 variables. What does n mean? The number of students. That will be 24. What does x bar mean? The mean. Okay? The mean is 1.708. And what does the question specifically ask us? Read the last couple of lines. Correct to one place of decimals, which is 1.71. Are you happy with that? Okay. Now lads, I have now, number 11. Prove that the angle AE bisects DAC. What I'd like us to do is mark off each angle with a number to represent it. Okay? So what you want to prove is that the angle DAC, which is marked here in pink, DAC, you want to prove that DAC is cut in half by these two angles here. In effect, you're trying to prove that the angle DAE equals what, guys? Angle EAC. You're trying to prove that angle 1 equals angle 5. That's your goal for this question. Okay? Now let's begin. What can we say about angle 3 and angle 4? Why are they the same? Isosceles triangle. Okay. What can we say about, let me see. We want to relate the values of 1 and 5 to 3. So, does anybody see, there's two letters I'm asking you to look for. Do you see any Z's or N's? Or do you see any F's like this? So, for example, this one is alternate angles where they're equal. Or this one here is what's called corresponding angles where they're equal. Does anybody see anything? Owen, what are you telling me?
Angle 5 is angle 4.
Angle 5 equals angle 4. What reason?
Alternate angles.
Alternate angles. Okay. What about angle 1? Angle... Trying to figure this out now. What about angle 1? If we were to elongate the line, see this line here? If we elongated it, what could you say about angle 3 and angle 1? Why? No, not necessarily. It's not the full exterior angle alone, so you can't use exterior angle because it had to be angle 1 plus angle 5. Okay? But what about this one here? Corresponding. Do you see anything with an F in it? Where these two lines are parallel and they have one line cutting through both of them. Anybody see it? Which angles are equal then? 1 and 3. See, if I was to draw it out here, guys, it'd be, look at this. There is angle 1 and angle 3 representing that F there, okay? So, angle 1 equals angle 3, and what's the reason? Corresponding. Okay? What does that mean? Angle 3 equals angle 4. That means that angle 5 equals angle 1. And is that what we're asked to do? Angle 5 equals angle 1. Now, the next question after that is, would this... just read the shoe here. I have it here. Would this result in part A apply to AB and AC if they were not equal? So would this result apply if AB and AC weren't equal? What's the answer to that? Why is it no, Dennis?
The triangle would be isosceles. So.
No, because the triangle wouldn't be isosceles, and therefore you can't use your proof. Well done. No, as triangle wouldn't be isosceles. Okay guys, you're to continue working on sample paper A for the next day. Okay? And what question?